Data analytics. We hear this phrase all the time. You know, it's interesting because it's not a new thing. I am reminded of two sort of interesting historical data analytics pieces, which I really rather like. One of them was in the 1850s, a cholera epidemic in London. This was essentially the beginning of epidemiology. At that time, cholera was thought to be an airborne disease, and a John Shaw, a physician in England, actually took a map of London and he mapped the cholera outbreaks on the map. And then he did what we would call nearest neighbor now, but essentially what place is the center of that, what's the epicenter of that attack? And what he discovered was it all boiled down to one water pump in downtown London. And all the cholera came from getting water from the one water pump. And he convinced the city to shut it down, and the cholera epidemic disappeared. And this was essentially the beginning of epidemiology. That's big data, done very manually. Pieces of paper, a map, and John Shaw did it. I think a better one for our purposes, just to sort of think about big data, was actually in the Second World War. The British Air Force and the American 8th Air Force that were flying out of England to bomb Germany were suffering horrendous losses. I can't remember exactly what the figures are, but they were incredibly high. So the command of both air forces looked at the idea of losing weight on the bombers, i.e. not carrying as many bombs, and replacing that weight, using that weight for armor. Well, you can't armor the entire airplane, so what do you armor? So this is an open scientific question. What am I going to armor on this plane to make it the most survivable? And so the way they approached this is pretty straightforward. As a plane landed, a team of scientists would go out and map every hole, every nook, every dink, every bullet hole, every shrapnel hole in the airplane. And they did this to every plane that landed. And then they mapped them out and decided where shrapnel was generally hitting an airplane and suggested that that's where you should armor. So this was all proposed and then sort of went up the chain of command, if you will. And it got to a fellow by the name of Abraham Wald, a Hungarian mathematician who was working in the United States at the time. And he attended a conference where this was presented. And at the end, he stood up and he said, "Gentlemen, these are the aircraft that made it back. The specific holes that you have didn't cause the airplane to fail. You actually need to put armor where there are no holes, because that's the places where a hole caused the airplane to fall out of the sky." So a different look at big data, which is looking at our assumptions of the problem in the first place. So it's interesting, we can collect data, but if we don't have some understanding of the underlying problem, the data may just reinforce a very bad choice. So big data really is about collecting a lot of data and looking at hypotheses and seeing how it supports or does not support particular hypotheses. So it's really nothing than the scientific method. It's just that we're using a lot of data to do it. What a lot of people mean by big data is that there is a machine learning piece that goes into that. So we don't need humans necessarily formulating a hypothesis. We can write programs that do machine learning of some sort or another that formulate these hypotheses. And again, many of these things are showing incredible results. Now when we move to computer security, it's a little different thing. If you look at cholera or the bombers, these were processes, if you will. The bombers certainly random distribution of metal that hit airplanes, or cholera, just a random infection of people who use the water pump. Computer security is not a random event. It is a deliberate attack. And there is a problem with machine learning and big data when you look at deliberate movements in those things. It is possible for an adversary to know your methodology, to know your learning algorithms, and to specifically design attacks that do not show up in them. What we see a lot on sort of higher end security breaches is the adversary will do reconnaissance against your system completely, and they will build your system, your networks, everything in a range, a cyber range, and they will practice against it until they can defeat it. Machine learning, data analytics, very, very good at finding machine-generated attacks and attacks that occur over lots of time with very little variance. A good example is spam emails, for example. But they're very hard when you've got a single person, for example, a hacker, for lack of a better term, attacking something, knowing that you have machine analytics looking for them. They can design an attack that will be very, very difficult for those machine analytics to actually find. And you also have to realize that in any big data situation, you can't necessarily trust all the data you get. Data has bugs, just like programs have bugs. They can be collected wrong, they can be biased, we can miss the pieces of data that we need, we can have an over-reliance on pieces that really aren't that discriminate of the underlying facts. Really good example, the last elections here in the United States, where all the polling data said that Hillary Clinton would win, yet that's not what occurred. So obviously there is an error in the data now, or the methodology that retrieved that data. The data analytics were there, and they came up with a particular ending, which was not reality, as it turns out. Data analytics aren't magic. It's actually hard to get it right. But we do use these, and we need to continue to use them, but they are not the solution. They are just one more part of the answer that we have to take into effect. And in some cases, they're really good at spotting some things, again, like phishing emails or people that show up at 2 in the morning to download lots of material, and that's not normal. Those sort of things, data analytics, machine learning, very good at. Finding the one guy who got a toehold into an admin of some place somewhere and manages to very slowly move laterally through the network from that initial breachhead, only when the people are at work and only as part of normal traffic. Very hard for data analytics to spot that. But there's a great future in data analytics. Again, because the things are so powerful, and they're powerful for a lot of reasons and in a lot of disciplines, but they are less powerful when you're looking at a human adversary, a thinking, processing human trying to outwit you. Because the basic algorithms underneath are not designed for that. At its heart, all data analytic algorithms are trying to say either here's the norm or here's what's different from the norm. And if what you are doing is part of the norm, doesn't ferret it out very well at all.